Hello, welcome to JambuOverflow final presentation. As you can see, this slide presents our entire team, including our professor. We are computer science students from the Federal University of Pará. Last semester we were enrolled in a software engineering laboratory class where Professor Clayton encouraged us to join the SCORE contest as a way of challenging ourselves. As a result, we worked in this project for about 4 months. But what made us choose the Lepic project? What drives us forward? Unfortunately, according to UNICEF, 154 million children worldwide are out of school during the pandemic. And that's also the reality of a country, as closing schools caused Brazil to go back 2 decades in terms of school dropout according to UNICEF. We were looking for a project that would be helpful, that would have a social impact, and that would become a product people would be using around us. And Lepic met all these requirements. Lepic is a software tool to support reading fluency assessment and management. It aims to help professionals that work with students' literacy, while at the same time encourage students' parents and guardians to participate in this educational process. Lepic's core features are upload a student's audio while reading a particular text, reading correction, get reading statistics such as reading time, an estimation of the words read per second, and providing a scale of possible deficit indicators. We'll talk more about Lepic features in our demo.
Let's see how we developed Lepic. First, perhaps the most important part, the software process. To define our process, we had to first acknowledge our limitations, and for obvious reasons, we could not hold face-to-face meetings. Because of that, we had to use video conferencing and instant messaging applications. The second limitation we had was the fact that most of our work should be done asynchronously, because each one of us had different schedules. Therefore, we could not work full-time on the project and in the same hours. Knowing that, we adapted Scrum for our needs. For instance, we did not use daily Scrums, since there were some days in which some of us could not work on the project. So we combined all other Scrum meetings into only one meeting that would occur at the end of every sprint, minimizing the time that everyone would spend on meetings. In our unique meeting, we would first talk about what worked and what did not work in the sprint and what should be improved. Then we would prepare for the next sprint, first by using planning poker to estimate the effort and priority of each feature. After that, we selected the features that were easier and had the highest priority. These selected features would be assigned a set of acceptance criteria, which the test team would check after development. We also used some agile practices that help us a lot, such as TDD, code reviews, continuous integration, and remote pair programming. Throughout the project, we used tools such as Microsoft Teams, Visual Studio Code, and GitHub for feature tracking and code versioning, Flutter and Django for the app, and Heroku to deploy our server.
For the requirements process, we used a mix of constant communication with the clients and some techniques. To understand the client needs, 4 interviews were conducted in a semi-structured way. This often involved some effort to handle the arrival of new requirements, prioritize the important things, and manage changes. To organize all the information collected during the interviews, we built user stories, a widely used technique to translate the client's needs in an effective way, considering the user's perspective. Other than that, we also built UML diagrams so the developer team could easily understand what must be implemented.
One key aspect of our success during the development process was the software architecture. We used an adaptation of the well-known clean architecture by Robert Morey. As we used TDD, we had to produce highly testable code, and for that, we found that this architecture helped a lot, increasing cohesiveness and create loosely coupled components. It made possible a clear separation of responsibilities, so that the team could work in parallel in different areas of the code. This was also crucial for handling fast and changing requirements. For the creation of the app interface, we started with wireframes and designed it on brainstorm sections. In the end, we opted for a minimalist design based on the previous iteration. For the interface usability measurement, we used the cognitive walkthrough method.
As mentioned before, our team adopted the TDD development process. We maintained the test cases derived from the requirements, aiming at a final product with high coverage, maintainability, and free of bugs. In our test methodology, the unit tests were organized in sets referring to each functionality, assisting automation and code coverage. Black box testing were applied in order to access the functioning of the system in border cases and with different inputs. Finally, the interface tests helped us to identify system usage problems. We experienced concepts that we learned during software engineering classes, such as the ongoing changes of the requirements, the agile methods, and so on. We also learned that the human factor matters. As the team worked remotely and during a crisis, it was extremely important to cultivate the good communication and team morale in order to move forward. Finally, we realized that it was extremely important to recurrently ask ourselves what really matters. This made us be in constant vigilance of the requirements and the contact with the clients, so we could better understand the priorities.
Lepic is a tool to support reading fluency assessment and management. Let's see how it works. If you're a teacher, speech therapist, psychopedagogist, pedagogue, or a researcher, this app was made thinking of you and what you need. To start, we need to create a class, give it a name, and a grade. Done. Now, let's create the students. For each of them, we need to fill in their name and last name. Perfect. Now we can give activities to our class. For that, we need to create a text. Type in anything you want or simply copy and paste a text you already have. And don't forget to give it a title. Text created. When you create a text for a class, all your students will receive it, but you can also give extra individual text to a student based on their previous results in order to help them to catch up with their classmates. You now need your student or patient's answer, which will be an audio of them reading the text. For that, you have two options. Record it yourself with the student or patient with a recording app of your preference. Or 2. Share the text with a guardian responsible for the student or patient and ask them to record it. To make it easier, sharing, recording, and sending the audio can also be done through your preferred instant message app other than email, because Lepic app accepts various audio formats. With the audio in hand, you can upload it to the app from your device file system. Alright, audio uploaded. Now let's correct the activity. Play the audio, select a word, mark it as an error, and add a comment. When you finish adding the text marks, tap to finish your correction. Great! The app now processes your audio and correction to generate some statistics about it. As a result, you can see the total reading time, the number of words read per minute, and the number of words read in the first minute. The number of correct words read per minute and the total number of words incorrectly read are also available. With all this information, you can notify earlier a student's or patient's reading difficulties and prepare personalized activities to boost their performance. You can also keep track of your student or patient's development with a graph visualization. The activities are sorted by date, and you can compare the results with a table of values suggestive of depth. With that, the app can contribute for an early diagnosis of a deficit or disability, which makes Lepic much more than a tool for text reading correction. But that's not all. We thought of a way of generating statistics about the class as well. When you're done correcting all the students' readings, you can also visualize a graph sorted by date to see your whole class development. With all this information, it's easier and faster to identify educational disparity earlier, between classes and between a student and their class. This finishes the cycles of Lepic app. Thank you for watching.
And what will happen next? The sponsors will continue the development after the conference. This project is open source and its source code can be found on GitHub, so volunteers are welcome. Thank you for watching, we hope you like it.
Okay, so thank you. The team is all here and Oliver Kopp has put some questions forward. Thanks for that lovely video and demo. I'm going to start quickly with the very first question from Oliver Kopp, who is here and can also ask questions if he's not satisfied with the answers. So, how is the speech related to the text? Does the teacher have to relate the words manually, or is this happening automatically? For example, the output word exactly appears at so-and-so. So, is Renan, are you or Isabela going to answer this?
Oh, I will answer.
Renan, okay.
Okay, so the text is about the speech itself that the student is reading, and the teacher will reads the text along in the app while it's listening to the student. So while it's listening, he will point to the words that are incorrect. So the teacher itself has to scroll the app to search for the text. This does not happen automatically.
Okay, thanks.
Good.
Answer.
Can I move on then, Oliver? Happy? Okay.
Happy.
The next one. How is the feedback sent to the students? Does the app support export of data?
Okay, so for the first question, the students are not the target for applications. It's most for teachers and clinicians. But we did ask our sponsors if we could add feedback for teachers and for the parents actually, and the answer was no, mostly because of ethical reasons. And if the app support export of data, actually not currently, but it's on our user backlog.
Thank you.
Okay.
Is that okay, Oliver, to move on?
Yeah. Yes.
Okay, finally, Isabella, I think you're going to answer the one on statistics. Is the statistics based on words? For example, student A has difficulty with words containing the letters AU. Is that shown somehow?
So the statistics are based on the previous research from the sponsors of the project, and they constructed a table of values, basically how many errors a student made, and that would be used, contributing to the second question, to identify the pathologies. They will have the, they will judge if is there any indication of pathology, and there is no way to know if a student has a problem with letter AU or any other problem. What happens is when you mark an error, you can add a comment. And since you are a teacher or a doctor, you are, how do I say it? You are following that children development, and then you know if they get more of this letter wrong or this expression they don't know how to say it, and things like that. It's more to state if they have a lot of difficulty or not. So that can indicate or not a pathology.
Okay, some relying on the tweeter, like that he knows, as he can interpret the thing. The app just collects data, and the teacher then has to interpret it somehow. Okay.
It's basically to help them to do their everyday task, which is to follow the students' reading, what they get wrong, and then try to get it better.
Okay.
Yeah, there are some statistics that the teacher uses and the researcher that can help them identify these issues, but this is up to them.
Okay. So 10 seconds, not enough time for another one, so it's okay for me.
So I think that's okay. Thank you, Oliver. I think we don't have enough time, but I think you answered three questions very well. Well done, everybody. And I think it's on to the next and last final talk now.
Thank you.
Thank you, everybody. Thank you, Oliver.
Thank you.